Rattలేదు. Hi all. I'm audible over the web to the people over here. I think he has gone to, yeah. So yesterday volume concept. How many of you are clear about it? Ever clear, Lera? So what was I doing for 1.5 hours yesterday? So why do we use volumes? What is the basic purpose of using a volume? The first reason is the data of your application remains present even though your container is deleted. That is the first thing. When you want to share certain piece of data across multiple containers, you use volumes. And yesterday, if you have seen my commands, that was all of it was about. For when I did Docker in the Docker file, when I said that volume user local tomcat, and I created the container, right? What was happening? There was a volume which was created which had data. So even though you delete your container, your volume is still there. So this is for the applications where you want to take backup. So for example, your application has been doing certain things and you want to retain that data. We use just volume. If that is not the case, you already have the data and you want that data to be present on your container or one container or multiple containers. Then we use volume mapping. In that case, I've used Docker run -v my system path colon some path on your container. Only these were the two use cases, right? Yeah. So any other doubts on that first before I step into the next union file system? ఇందా క్లియర్ కాదంటున్నారు ఇప్పుడు ఎవడు మాట్లాడట్లేదు. Yes. Any other doubts on that? Okay. So do we use volumes? We definitely use volumes. Why? Because whatever container has generated, we want that data even though after container is dead. If you have any application requirement like this, then you will create a volume. So the next question is, to which folder will you create a volume? To your applications folder, and whatever your application generates data, that folder. That's what we do. We would not create a volume for a complete thing. We will not take a volume at a root level. No, that doesn't make sense. All right. We create volume for application folders and application data folders. Let us assume that using Docker container, we can create MySQL containers also. MySQL is a database. And whenever you use database, taking a backup of a database is an essential activity. Yes or no? Right? And whenever you create MySQL, there will be certain folders of MySQL where your data is present. Yes or no? Yeah, we create a volume for that. Right? So these are all the kind of things which you do for your application data and for your application folder. Okay. Sometimes we skip application folder also because we know how to get it. It is not important. It is majorly for data. Any data which you want to have, even though after your container has been removed, stopped, crashed, in any scenarios, that is the most important. Make sense? Right? Okay. Wonderful. Now let us go ahead and discuss about one more important concept, which is called as union file system. Yes, please go ahead. Yes. Yes. If you don't create a volume, whenever you remove container, nothing is stored. Everything is removed from your system. Yes. Till it is running, you will have some folders. But once it is killed, you will not have that folder anymore. So if you remember, we had started many containers. Yeah, but when I did Docker volume ls, we were seeing only 4. When we started this exercise, that is because only 4 containers had volume sections out of all of which we have run. That's the whole point. Right? If you don't have volume, no backup. Right? For stateful application, that is an important activity. Okay, even though we say that application should be stateless, all of that, but in reality your company wouldn't like to basically change the behavior of application just because you are moving to Docker. Just because you are moving to Docker, they don't want to make code changes. అలాంటి కేసుల్లో అట్లీస్ట్ కొన్నాళ్ళు for some time you have to support this mode, and the best way to support this mode is volume. Right? What is a volume? Some mount on your system. Right? That's the whole point. Right? Now there is one more question. Let me look at it. By default container, yeah, definitely container creates a volume, but it is not persistent volume. What is a persistent volume? A volume which stores even though after the certain stuff is being done. Okay, the volume's life cycle is container being created till container dead. That is the volume, default volume scope. Once your container is removed, volume also will be deleted. But if you are explicit, like what we did yesterday, you create a volume, then even though you delete your container, your volume is still available. You can reuse it to other containers, you can take a backup of it, you can examine it, whatever that makes sense. Right? Yeah, that could be the case. Yes. Okay, I would not say user. I would say any volume that is explicit is persistent. Yeah. You said regarding config.xml used by multiple containers in the volume mapping. Can you elaborate on that? Okay. So let me not speak about config.xml, but let me do this. My applications, okay, my applications have a same home page. My application has a same home page, but the containers which are hosting my application are approximately 100. Now I need to change the home page. I need to change the home page. One way is go into every container and do the deployment somehow, whatever way that makes sense to you. Or all of the containers home page folder, okay, create a mapping on your system. Okay, now all the 100 containers have been mounted from one of your system folder, which is a HTML folder. There you go and change index.html. Then what would happen? That's the whole point. Okay, and now when it comes to config.xml, right, how do you change your what do you say, probably you might be using applications where your application speaks with database, and database might have some IP address, some host name. How do you basically arrange that stuff? For me to, before I speak about this, I need to speak about network. Before I speak about this, I need to speak about network. Once we speak certain things about network, then you will come to know how to resolve this. Then you will come to know how to resolve about this. But here we will be using something called as service DNS names generally going forward, but we have not gone to a position where we understand what a service is. So that's why I'm not basically speaking about it. But the whole point is, in your config.xml you will put an IP address of some container, right? So how can you put that? Can't you use it while you are starting your container? Yes, IP address of your container is a variable, environmental variable, right? Or there is one more kind of a variable in your Docker file which is called as argument. There are two kinds of variables. One is environment variable, the other one is just argument. Okay, so what you would do in Docker file is, you would say that, let us assume this is my Docker file. Okay, let me minimize it, or I'll be using this stuff itself. Okay, this is my Docker file, and here I write from something, right, label, maintainer, whatever it is, and then I will be saying arc, okay, db underscore name or host, whatever it is, okay, equals to something, whatever it is, default value. Now while I'm running the container, I will say docker run something like -e db underscore name is equals to some IP address of the container where I have DP. Make sense? This is what you do with configurations. Okay, you will give this value while you are running the container, because you will come to know the IP address of certain things when you are running the container, not before, or while you are writing your Docker file you will not know the IP addresses. So that's for that reason you might use something called as arguments or environment variables. Both are same, both can be passed while you are basically starting your container. The only difference is when you use env, it acts as an environment variable in that Linux container. If you use an argument, it has nothing to do with environment. So that's your decision. Okay, for now you can safely assume I will be using environment variable, and you can go into the configuration file and you basically, while you are starting your container, replace that with string replace. That's what you do. That's how you do that stuff. Make sense now? Anything that is dynamic will become either an argument or an environment variable. All right, both are same for our cases, but when you define it as a env, it can be used basically as an environment variable within your container. If you use it as an argument, it has no scope. You have to just use it in the Docker file script itself. That's the whole point. All right, okay. Yes. Hmm. If your source is Windows, if you are running it from Windows server, and if you are doing taking Windows folder, that would be the case. If you are taking a Linux folder, even that is the case. If Linux asks, do you want to overwrite, yes or no, the same thing will be done, obviously, because we are copying it manually, right? Yeah. Or while copying itself, you can say that force copy. Okay, fine. Then let us speak about most important thing, which is union file system. Whenever we ran Docker, or whenever we created Docker image, we got what? Image layers. What is responsible for image layer? Every run statement will lead to one image layer. So can I safely say this? Okay, let us assume, okay, let me expand this. One layer, so if my container is using 3 layers, these are those 3 layers, right? Now if on my image, whenever I am saying that with every run statement you get one image layer, this is how it looks like. All right, that is good, fine. Now why we use image for? Image enduku vaadtam? To build it or to create a container at the end of the day, right? So let us assume that these are your image layers. Generally image layers will have IDs, the like container ID, every image layer has its own ID, but for easier purposes I am calling this as 1, 2 and 3. I'm just numbering it, but actually you will have IDs, right? So these 3 layers. Now whenever I create a container, okay, I should have data from all of these 3. Do you agree to that? I should have a data from all of these 3. So ideally what would happen? These 3 will be combined to form one sort of hard disk, right? That's what our basic understanding is. ఈ మూడు combine అయ్యి ఒక hard disk లాంటిది ఫామ్ అవుద్ది, అది container కి attach అవుతుంది. Okay, so let us assume this hexagon is our container. So our basic assumption would sound something like this: all of these 3 will be combined, or this is a basic common sense of what we have learned all these days. It will sound something like this: all these 3 will be combined to form complete file system, and this will be used by your container. And whenever other container comes up, the same thing happens again. So with every container this stuff happens, right? This is what our basic understanding is. But containers doesn't work this way. Containers work slightly differently. What they do is they use something called as union file system. What is union? In set theory we learn union, right? Union is when you combine multiple things. So what they do is they combine these multiple image layers, right? And with every container, whenever they create a container, every container will have one more layer with it. Every container will have just one layer. Okay, so this I will call it as thin read write layer. Okay, so now whenever a container is building, the view it will get is union of thin read write layer plus 1 2 3. అంటే మీ కంటైనర్ లో కనిపించే ఫోల్డర్ స్ట్రక్చర్ ఎలా ఉంటుందంటే ఇట్ ఈస్ ఎ యూనియన్ ఆఫ్ యువర్ ఇమేజ్ లేయర్స్ 1 2 3 and your read write layer. Okay, now let us assume in this layer I have created a folder called as user local tomcat. Yeah, so generally in the container, can I delete it? Yes or no? You can obviously delete it, right? But deleting means does it need to change the image layer? Ideally the answer should sound like yes, but what happens is the delete option is recorded here. If you want to make any changes, you will be making changes on the topmost layer where the container has write permissions. Container doesn't have a write permissions on these three. The only layer where containers has write permissions is this, right? Now here let us assume we deleted. Okay, so let us assume user local tomcat. Remember, this deletion will not be impacted or will has nothing to do on the image layer, but it will be marked as deleted on the read write layer. And whenever Docker wants to see the contents of that folder, a union is created, and in the union topmost layer is saying that this folder is deleted, so don't show it. It is an illusion. Ideally it is not deleted from your image layer, it is deleted from your union file system. It is deleted from your union file system. Why do you want to do all of this nonsense? Why do you want to do all of this nonsense? So let me just try it mathematically. All these three disks combined, let us assume that it is 1 GB. Make sense? Three image layer sizes 1 GB, right? And read write layer, let us assume it is 500 MB. It will not be that much huge, but I am just combining this for mathematical simplicity. So my container's hard disk might be somewhere closer to 1.5 gig. Make sense? Right? Now I bring one more container. So what would be the size? 1.5 gig into 2. So total 3 gigs. In this story, if I use layer system, only 2 gigs, because 1 GB is fixed. You are not allowed to change it. The only place which every container is going to change is the read write layer part of it. So every container will get very thin read write layer. Any operations which they do during their life cycle, they are not changing anything on the image layer, they are changing on their read and write layer. Okay, so any changes which we do on the read and write layer, if you want to persist, we are using volumes anyway. మనం ఏమైనా మారుస్తుంటే రీడ్ రైట్ లేయర్ లో అంటే దాంట్లో మనం ఏమైనా మారుస్తున్నాం అనుకోండి, దాన్ని మనం వాల్యూమ్ లో బ్యాకప్ తీసుకుంటాం. వీఆర్ టేకింగ్ ఎ బ్యాకప్ ఆఫ్ వాట్ ఎవర్ చేంజెస్ విచ్ వీ హావ్ మేడ్ అండ్ విచ్ వీ థింక్ ఆర్ నెసెసరీ ఇన్ ద వాల్యూమ్స్ ఆల్రెడీ. So the whole point is this is optimization. So even if you launch 1000 containers, it will not be 1000 into 3 GB. It will not be 1000 into 1.5 gigs, right? It will not be that. It will be 1 GB plus 1000 into read write layer space. So what is happening over here? You are optimizing disks. You are not repeating the disks. You are not making redundant information out of it. Since this file system works on a concept where it has multiple layers, and to see the actual data you have to union them, you have to combine them. That's why this file system is called as union file system. This file system is called as union file system, specifically written by Docker. In this union file system is implemented by multiple different drivers. The Ubuntu driver is something called as AUFS, augmented union file system. Okay, Red Hat has its own implementation. The whole point is, but the conceptually this is what a union file system is. Okay, so whenever you create an image, you get image layers, and those image layers are fixed. They are not going to change in their lifetime. Okay, and whenever container tries to make any changes, it is not making on the image layer, it is making on its read write layer. Okay, the changes which are made in the read write layer are propagated because it is union, because it is combination. That's the whole point. Is it making sense? Yeah, any doubts on this? This has nothing to do to show, because I can't show this. మీకు అర్థం, నేను ఇది ఎలా చూపించాలంటే నాకు చూపించడానికి వేలేదు, బికాస్ దిస్ ఇస్ అ ఇంటర్నల్ ఇంప్లిమెంటేషన్. యూ విల్ నాట్ బి ఏబుల్ టు విజువలైజ్ దిస్, బట్ దిస్ ఈస్ హౌ డాకర్ వర్క్స్. Okay, so whenever we build docker image, right, we had layers, right? Those layers will stay as it is. Any changes which you are making in your container is done on the container's thin read write layer, right? So, and the Ubuntu, basically this concept is called as union file system, and this is implemented in Ubuntu as AUFS, augmented union file system, right? Yeah. Okay. Whenever you create a docker, a volume will be created. It can be anything. It is id, it is not name. The one which is used by docker engine. Hmm. Yes. Yes. Where lib docker folder, all of the docker database is in that where lib docker. Yeah. Okay, can you explain the image layer once more? Okay, in what other files we will use environment variable? Okay, environment variable is just used for the same. For example, you have java, right? You want to basically set the java home variable to a different folder. That's where the environment and argument difference comes into play. Environment variable cannot change anything, it can change anything in your system, okay, based out of the argument level. If you use argument, it is just a value, it cannot change anything, it is not a system parameter, it is just a variable in your docker file. Argument is a variable in your docker file. When you use env, that is an environment variable in your container. So how much long time do you want your variable to persist? If you want your variable to be used while your container is running, then you use environment variable. If that is not the case, you just want to make a decision based out of some value passed by user in your docker file, then you will just use argument. All right, scope is different. అంటే ఎన్విరాన్మెంట్ కంటైనర్ ఉన్నంతసేపు బతుకుతుంది, ఆర్గ్యుమెంట్ అనుకోండి డాకర్ ఫైల్ ఎగ్జిక్యూట్ అయ్యాక చచ్చిపోతుంది. It doesn't have a scope after that. That's the difference. So how much long time do you want the user is passing? That's the difference, right? So can you please explain image layer once again? Okay, so let me do that. Okay, before I do that, let me log in inside the. Hmm. They're changing the EC2 IDs to longer IDs, so that because the usage of EC2 has increased and they cannot maintain distinguish that, just like IPv4 to IPv6 transition. They are giving that resolution how to do that in the cases, right? In the same mail, when you see how to basically do it, they ask you to do certain things, you have to follow that. It would have an impact, okay, but if you follow that, the impact is minimal. Okay, let me log in. Okay, so docker ps, yeah, let me remove all of them. Docker rm -f docker ps -a. Okay, wonderful. Now let me use docker images, right? So let me take an image which is tomcat. Okay, docker inspect tomcat. Okay, what is that I have? Okay, I have to use a specific version. Fine. Docker inspect nginx. I'm lazy, guys, I don't want to type more. Okay. So are you seeing layers? Root file system, and then you have layers. And then there are 3 layers. With every layer, there is something called as SHA 256. Okay. All the contents of your hard disk are basically that layer. And how is that layer ID calculated? Okay. What is how many of you know what a hash is? Hash? By any chance? No? Okay. So for the people who don't know hash, basically the concept of hash is when you give an input into the hashing algorithm, okay, it will always give you fixed output. It will always give you fixed output. But there is one important property. No matter how much big your text is, it will always give you the fixed text. So for example, let us assume that it will give you 60 bits of data. I give one string, output is 60 bits. I give the complete book, output is 60 bits. That's a hashing algorithm. Okay. Two hashes will be same when you pass the same input. Two hashes will be same when you pass the same input. Right? There are many admins in the room, right? So you do something called as checksum. What is the purpose for that? Why do you use checksum? When you download a Ubuntu image, you will see something like checksums available. What is the purpose of it? Yeah, checksum is your whatever you are downloading. If you pass it through a certain algorithm, it will give you some number. When you download it from the external world, okay, let us assume that you are downloading Microsoft Office. Microsoft Office says that my checksum is some number, right? Someone has hacked and put some extra stuff in that. So whenever he makes some changes, a new hash will be generated or a new checksum will be generated. Now you will download the download the file, you will create a checksum, and then you will take the checksum from Microsoft. You will compare these two. If these two are same, your software is not tampered. Otherwise, your software is tampered. Now what I would do is, let me go to this SHA 256. I'll not go to algorithm. Algorithm is too much for us. Okay. Let me go for calculator. ఇంజనీరింగ్ లో ఇది కూడా 16 మార్కుల క్వశ్చన్. హైటెక్ సిరీస్ లో చదివేసి ఉంటారు మీరు అందరూ. రైట్, fine. So see how it works. I give a text which is called as hello. What is happening in the back? Is there some number that is generated? Yes. See the first 4 digits. Yeah, the only thing which I go and change is I make this change from small h to capital H. Is the ID same or is it changed? Okay, I'll put it back to hello. Am I getting the older value back? So the basic concept is, with by minor change also your hash changes. For example, I go to the hello and I add one more space. Hash is same or changed? So for every text it will get a unique hash. Okay, here there is lot of mathematical algorithms that are used. Okay, so basically what happens is, for whatever content which is there present in my image layer, all of that will be passed over here and I will get a hash, and that hash is nothing but your volume ID. Okay, now let us compare this string with whatever we are seeing over here. Does they look the same? Yeah, they might be different values. I'm not saying values are same or not, but if you see the length, right? So your image content is basically combined, given to a hashing algorithm called as SHA 256, and it will give you a number, and that is nothing but your volume ID or image layer ID. Okay, in Docker, every ID which you are seeing is SHA 256 hashed, right? So now tomorrow when I create a different content, tomorrow I create my image layer, right? And when I create my image layer, whatever contents of it will be basically hashed again, obviously, and I get a number. If that number is matching to the existing number, it will not recreate, it will reuse. Are you getting the whole point? Okay, so let us assume that I have three text files which has the same content hello. For hello, what is the hash? Is it same? Yes, my 3 contents have just content called as hash hello. Now contents of my file have the same hash ID. What do they mean? They have the same content. They have the same content. So there is no need for you to save it 3 times, save it only once. So rather than saving this hello 3 times, what I will do is I will internally I will create a hash ID, and in that hash ID I'll write hello. So let me just show you a visual representation of it. You got that context, right? I have 3 files. 3 files have content called as hello. 3 ఫైల్లోనే hello అనే రాశాను, right? I want to store it in some format. So one way is store 3 times. Store 3 times, no problem, good. But are you optimal about it? మీరు ఆప్టిమిస్టిక్ దాని అది ఆప్టిమల్ అప్రోచ్, ఇంతకంటే బెటర్ అప్రోచ్ ఏమైనా ఉందా, మనం ఇంకా ఆప్టిమైజ్ చేయొచ్చా? సో దెన్ వాట్ ఐ విల్ డూ ఇస్ I'll create a table. Okay, I'll create a simple table with with key and value. Make sense? All right. So here what I would do is I'll put the hash, whatever hash which has been generated, and then I will say for this hash the content is hello. This is how I store internally. Now my 3 files have same content called as hello. So how many times do I need to save? 1 time. But if you are saving it in the normal approach, how many times will you save? Are we not optimal about it? Because our key is same, content is same. Okay, tomorrow you change one file's content from hello to hi. So now you will have 2 files which use the same hash, and then you would have one more hash over here, which will have something called as hi. And tomorrow in the near future, if there is any file which is created with the content called as hi, I don't need to create a space for that. I need to just map it to the hash ID saying that there is already a content, you are using the same thing. Is it reusable? Ardhamainda ee concept? Exactly the same concept is being used in image layers. So that's why whenever we say docker pull some image ID, we get sometimes saying that already exists. How does it know already exists? Because it keeps tracks of just keys. హ్యాష్ ఐడి ఉందా లేదా, ఈ హ్యాష్ ఐడి నీ సిస్టంలో ఉందా, ఉంది, ఉంటే డౌన్లోడ్ చేయి, లేదు డౌన్లోడ్ చేస్తుంది. దట్స్ ద బెస్ట్ పాయింట్, బికాస్ యూ కెన్ సేవ్ సమ్ డిస్క్ స్పేస్ if you create reusable image layers. So writing multiple run layers can lead to optimization. All right, that's the whole point. You might see certain times the file with multiple run statements, but this is the whole reason for that. This is the whole reason for that. So in Docker, whenever you have 2 images which have the same contents, it doesn't mean that it is stored twice. It is stored only once, because image is not stored as an image. Image is broken down into something called as image layers, and every image layer will have a hash ID, right? And now all of these image layers will be unioned to form a file system. All right. So now if you see in this image, we are seeing, yesterday someone had asked me this question saying that how can I find out how many image layers are there? I'm not sure who had asked, but I forgot that. But are you seeing that now? Docker inspect, and then you basically select this, you are seeing it. That's the whole point. Looking good, right? Now let me create a container out of it. Docker run -d nginx. I'm not interested in ports and mappings because I'm not interested in to make this to check whether this application is working or not. All right. So now I do Docker. This is my Docker's SHA-256 ID of my container. All right. I'll copy, or you can do Docker PS also. In PS, you will get the shorthand notation of your same SHA-256 ID. Copy this. All right. And then say Docker inspect and pass that ID. See what happens now. Let us get into the storage aspects. You have to scroll through. There is a hell lot of information. Are you seeing there is an image, and image has a ID over here? Fine. Okay, so let us come down. It doesn't have a volume, so that's why you're not seeing any information about it, right? But if you see, the logs of this container are stored over here, the image is over here. Now whenever you want to know what are the image layers, you can just inspect on your Docker, you will get an image ID. And now you inspect on your what do you say, you inspect on your image, you will get the layers, you'll get the layers. Now let me just go to this folder. Okay, let me become a root user so that it will not ask permissions. It is easy for me to navigate. Okay, so what is that you are seeing? You are seeing resolve, host name, all of that, all of the data of your containers. Now let me come one level deeper about. So every container has, we are running only one container, so there is a folder that is being created which has a containers ID. Now let me come one level above it. What are the other things which you are seeing over here? Volumes, yes. CD, volumes, right? You do ls, you have all the volumes that you have, and here you have a disk, right? Docker volume ls will show you the list of all of the volumes, right? Now this list is nothing but all the contents of this folder, nothing but blindly. If you see, you compare those three things. We have the first one which starts with 0235 02355, second one 47f6. These are the contents of it, right? Now let me do docker volume inspect, right? And then copy this volume id. What is it trying to tell? It will try to tell when it was created, what are the labels, what is the mount point, and what are the different things. Now you try to do it for everything, you will come to know what is the volume, what are the labels with it was created, and you will get a whole lot of information. Similarly, docker inspect nginx, right? Here you will get layers, and apart from that layers, you are also getting some directories. This is a place all of the stuff would be merged on. So internally it does hell lot of things, internally it does hell lot of things. So docker hard disk is no longer one stuff, it is combination of multiple image layers. So when you create multiple containers, right? So what are the different things that will be different with respect to the docker? Only read and write layer, only read and write layer. Image layers not going to change. Image layers are read only, not write permissions. No one has write permissions on image layers. The only place where a container has write permission is thin read write layer. Okay, so the organization, if you want to represent it graphically, would basically sound something. Okay, this is not a clean image. Let me go ahead and very quickly. Okay, two containers from the same image. Okay, and image has layers, right? And the container will have thin read and write layer, right? And whenever it wants to access the storage, let us assume that this is nginx, okay, one, this is my container's name, and nginx 2, this is my container's name. These are thin read write layers, and these are image layers. Image layers can be found out from your image. Whenever you are building an image, you might have written multiple run statements, and every run statement leads to the one image layer. Now in the nginx one container, the storage is complete. What is it? It is a union of, it is a union of all of this. Making sense? And for this container, it is union of all of this. And now whenever you make changes only here, because these are read only. These are not write permissions, right? You want to delete a folder, you have deleted the folder, but delete happens only on the topmost layer, which is your read and write layer, not on the image layer. So you create thousands of containers. Okay, there is some sort of optimization or not? Yes. So with respect to hard disk, the only thing that happens on the container apart from images, the hard disk which you are seeing in your container is nothing but combination of image layers plus one read write layer. A read write layer is created for every container, and it will have its own size. Okay, so whenever you basically do this docker, sorry, docker images, are you getting size? What is the size of the Nginx latest? 109 MB. Now docker ps, okay, you take the volume of it, and if you measure the size, okay, it might be same, or it might be same plus size of read write layer. That's it. That's a math. That's a very simple math. All right. So hard disk of your container is nothing but combination of multiple image layers. To combine this layers, Docker has written its own file system, which they call as union file system. And this concept is taken and implemented in every operating system. Since I'm using Ubuntu, whenever I install Docker engine, they will get something called as augmented union file system. Tomorrow with OpenShift, you might get some other implementation, but the concept is they try to implement this. Did you got the point? So Docker has optimized storage, right? Docker has optimized image creation, right? It is working all together wonderfully. Now, what is the other important layer which is very important apart from this? We have spoken about CPUs, the basic container being running and getting everything processed and all of that stuff. Next is storage. What is the other important area? Network communication. How do they basically communicate with each other? How is it possible, right? How are all those things happening? That's my next point of discussion. But before I go there, is it looking better now? Yes. Is Docker optimized on all fronts? Yes. But remember, these optimizations look very good whenever you have application in your mind. But whenever you think of maintenance activities which you generally do on your hard disk, it might not sound great. Okay, there is a lot of confusion. I need to go to that folder, I need to go to this folder, okay, I need to do docker inspect, then only I'll come to know what is the path, all of that. Yes, that is all correct, but it is optimization. It is optimization for your applications. Yes. Okay. Yeah, let me answer the web questions and then I'll take your question. Right. How container decides this container should have these many image layers? Docker will not decide basically. Okay, while you are building a image, I have said that every run statement leads to creation of image layer. It is our choice rather than Docker's decision. It is our choice. While running Docker file, which is writing an image, you have written something like from Ubuntu or from something, right? Maintainer, and then you have said run apt-get update and apt-get install nginx, something like that, right? Then you write one more run statement. So your image is taking your images layers of Ubuntu or layers of your parent image, plus you have written two run statements. So that is, let us assume that the parent image has 3 image layers already, and then you have written 2 more, so it is 5. So in your image layer there is 5. There is a math around it. It's not a decision basically. That's how it works. Every run statement, one image layer, right? Okay. Does kernel is thin part of this layer? No, actually Docker engine uses kernel. Docker engine uses kernel. It used to use Linux kernel a lot. So what used to happen was, for all of these flexibilities, Docker used to fail whenever there was a Linux kernel release. Docker used to fail whenever there was Linux kernel release. So that's why what they have written is, they have written a utility which is called as libdocker or docker lib, a library which is capable of speaking with Linux kernels and getting the job done, right? And this implementation doesn't really worry whether your kernel is same, whether it has changed. But whenever you are working on earlier versions of Docker, right, things which used to work suddenly used to stop working because there was a new kernel upgrade. So then Docker decided that this is not a way to go. So they have came up with their own core, which they call it as lib Docker, which is part of your Docker engine. When you install Docker, you get lib Docker, right? So similarly, going forward, you'll be seeing something like lib network. So anything which you see with lib in Docker world is they have written their own implementation. So to overcome this kernel release mismatches, Docker has written its own procedural calls, which will make calls with multiple Linux kernels or multiple low-level calls and get the job done. So that's how it works, right? I was in assumption that these layers are revisions of image configurations. Now I got clarity with Union File System. Wonderful. If you got clarity, nothing like that. Okay. Yes. Mm. Yes. Yeah, earlier that was a serious problem, but now with libdocker component in your Docker engine, that is the least area to be worried about. Mm. Yes, yes, yes. So how do you maintain high availability? Exactly just like what we do for our systems. We will not create containers in one system. We would try to go to multiple systems, and then we would have some load balancing around it. Exactly like what we do in the not general scenario. That's it. Mm. Yes. Yes. That part, yes. So that's why yesterday whenever I was downloading Tomcat colon 8, there were many places where you have seen already exists. There are two, three or four new areas which it has tried to download. That's how it works. Okay, now networking. All right, so very important area, right? When we speak of networking, here the problem is we need to speak about two kinds of networks. One is called as a single host network, the other one is called as a multi-host network. What is that nonsense? Single host network, what does it, how does it make sense? ఒక machine network కావాలా, right? But remember, in single machine, are you creating one container or multiple containers? Multiple containers. So that's why, since we have multiple containers inside one machine, we also need to speak about that area. That is single host networking. Single host networking is within one operating system you can create multiple containers, and how can these containers speak with each other? That's the first case where we speak about single host network. Then comes the multi-host networking. You have multiple servers and multiple containers. So how does this combination work? So Docker networking is just this single host and multi-host. And then comes a lot of networking stuff. How do you want to communicate? Okay, what are your implementations and all of that stuff? Make sense? So single host networking doesn't mean that for one container. It is for one physical system or one system where you have installed Docker, and in that Docker you are creating multiple containers. So these containers needs to speak with themselves, right? So for example, you create two containers. One is your app server, the other one is your DB server. Do they communicate or shouldn't they communicate? They should communicate. So how are they going to communicate? How is this going to happen, right? So what are the default stuffs which we get? Okay, for Docker volume checking, what was the command which we have used? We have used a sub command called as Docker volume, and Docker volume had its own stuffs. So we will be exploring one more such area, okay, which is, you can guess by now, Docker. So what are they? Okay, so what are these components? So you will have again Docker network. If you type, you will get the capabilities much like what you have seen in Docker volume. Okay, inspect, create, prune, remove, all of this. All right, so we'll be speaking about these things, right? Yeah, I think this is our next important area. And in this important area, we will come to know about two important ways which you are going to go forward: Swarm, Kubernetes. Swarm and Kubernetes will slightly be introduced over here. What is the difference, right? How they are procedurally different. And then once we finish this concept, okay, I'll be speaking about some real-time use cases, and then we'll be moving across from Monday to Kubernetes world, right? If I finish Kubernetes earlier, I'll not take Swarm, but I'll be taking one interesting area which has came up quite recently in Docker, which is called as Docker stacks. Docker stack. Not known to many people right now. Not many are using it, but looks good. Looks good. So it is not an important area. It is just think if we have time, we will discuss about it, right? And I am not discussing about Docker Compose, but I will share some articles. It is very simple. Docker Compose is when we are running commands, right? We are running command to start one container. So if I have to start 2 or 3 containers at one shot, how can I do that? So that is called as composing in Docker. So that's the other area, because we have more important areas than Docker Compose to cover, because we have to look at ECS and ACS. ECS is Elastic Container Services from AWS, and ACS is Azure Container Services from Azure. So that is more important than these two areas. Okay, that will bring in you more jobs and more areas to work. So we'll be discussing about those two areas. Okay, if because Docker, whatever I'm discussing, if you say that did you covered everything, I would say no. There is hell lot to more. There are many areas which even I don't know. I have not worked on. So, for example, you can go into the Docker and implement your own networking. So we are speaking about only application networking, right? But for example, you are in a hardware organization where they are checking network protocols. So you can use Docker to create your own networking protocol and then test your containers based out of it. So we are not that. Okay, Docker ikkadto avala. Docker inka chala undi. But the Docker which we are covering is general to meet general application needs, right? Which can get you jobs and which can you work you in normal environments. But there are very corner environments where you can do customizations. I am not speaking about any customization, right? So Docker is a very interesting area, very decent area. There are many orchestration companies which are living only on Docker. For example, you might have heard about OpenShift. You might have heard about Nomad, right? These are clustering on top of Docker and Kubernetes. Okay. So for the people who are worrying about OpenShift అవసరం కదా అని, OpenShift Kubernetes కన్నా అవసరం కాదు, రైట్? OpenShift అడుగుతున్నాడంట. మీరు ఒకటి గుర్తుపెట్టుకోండి, ఫర్ ద పీపుల్ హూ ఆర్ సర్చింగ్ జాబ్స్, యూ విల్ నాట్ బి 100% మ్యాచ్ టు ఎవ్రీ జాబ్. రిమెంబర్ దట్. అండ్ యూ కాంట్ లెర్న్ everything that is there in Naukri. Okay. And if you know me from last 1 year or 2 years, when I know that something good is going to happen, I change the syllabus. Okay. For the people who have joined newly, you might not know, but when we started, our syllabus was not this. మన డాకర్ మన డెవాప్స్ కోర్స్ మొదలు పెట్టినప్పుడు మన సిలబస్ అసలు ఇది కాదు. ఓకే. సో దాని గురించి వరి అవటం వదిలేండి, అది నా తలనొప్పి. మీకు ఉద్యోగాలకి వర్కింగ్ ఏం కావాలో నేను చూసుకుంటా. కాకపోతే నేను చెప్పినవి చూడకుండా మిగతాయి చేసుకుంటున్నారు అనుకోండి, అది కావాలి ఇది కావాలని, ఐ కాంట్ హెల్ప్ ఇట్. రైట్. నా పని కూడా మీరే చేసేస్తే క్లాస్ కూడా మీరే చెప్పండి, గొడవ లేదు. నేను వచ్చి కూర్చొని రోజు కొత్త బట్టలు వేసుకొని. రైట్, ఫైన్. సో we will take a break and then we will discuss about Docker network, which is a very interesting and an important area which will lead us to the importance of Swarm and Kubernetes. Right? Yeah. Thanks. Okay, we might not cover Docker Compose. I'm not sure. Okay, because for me, my attention is not on Docker Compose. Fine. Okay. In the meantime, while you people get settled, I am launching 2 more machines. Okay. First, let us look at Docker networking, right? So first we need to speak about networks not between our systems, network between our containers, network between our containers. So okay, let me just Google this. This I always forget. I said right, Docker generally when they come up with containers, they will not be very large. They will just have very limited functionality. So when you create a container, you will definitely not have the basic stuff also, right? So now for us to test something, we need ping utility so that we can ping onto the other system. Now what I'm trying to do is I will be downloading the Ubuntu image, Ubuntu container image, right? And then I'll be creating containers and I'll try to ping it. Okay, and then we will come learn about Docker slowly, right? So first let me do this work and basically get ping ready. I think if it was IP utils, yes, I think this makes sense, right? Okay, now Docker pull Ubuntu. I am pulling Ubuntu container. And what is a Ubuntu container? I think I've said it on the day one. Ubuntu container is nothing but Linux kernel, and in that Linux kernel what they do is basically on the root file system they will copy the tar. The tar consists of all the changes of whatever is required for Ubuntu. So that's why that's nothing but a Ubuntu container. Now let me get into it. Docker, first let me kill the existing containers. Okay, so Docker run -it interactively a container which is Ubuntu, okay, with a tag which is 16.04, and I want to get into bash prompt bin slash bash. Fine. I try to do ping, not found. So that's the whole problem which I was trying to tell about. So sudo, there is no need of sudo, apt-get install iputils hyphen. Oh no, it's not working. Let me try once again. Yeah, yeah, fine. Now I have ping utility. So basic stuff which I need to do, because ping will not be present, I have to do this job, right? Otherwise you will not find a container with ping, right? For example, now let us basically try to create a image which is exactly this, which is Exactly this, a Ubuntu image with ping installed, so that we don't need to execute these commands again and again. So shall we write an image? Yes. Okay. So cd images, make dir Ubuntu with ping, cd Ubuntu with ping, vi docker file. Now రాసుకోండి, మీరు గమ్మున రాస్తారు, నేను గమ్మున రాస్తాను, చూద్దాం. ఓకే, యు నో ద స్టెప్స్ రైట్. ఎవరైతే రాస్తున్నారో చూడకుండా రాయండి, చూసి కాదు. ఫైన్. ఫ్రమ్ Ubuntu colon 16.04 maintainer. I'll be removing this maintainer from my next class because it is deprecated, but for now it's okay, it is not removed yet. Qt run apt-get update and apt-get install iputils, sorry, hyphen ping. Will it work? Yes. When you execute this, it will ask, do you want to continue, yes or no? Whenever Docker sees that, it will kill your image creation. So we have to give -y. Okay. CMD, as usual, I'll be writing echo created. Fine. Simple. Yes. Now I'll be building the image. Docker build -t my Ubuntu. I'll build the latest image. I'm not worried about versions right now. Okay. And my image is present at, my Docker file is present in the current directory, so I'm giving dot. If it is present in the different directory, I'll give the directory's path. Simple. So I have basically an image which is capable of pinging. That's it. Okay. Since Ubuntu doesn't have it, I have written my own image file. Okay. Now let me get into it. Docker run -it my Ubuntu /bin slash bash. Okay. Now I can say ping working. So I have an image which basically builds, which is basically Ubuntu with ping. All right. Good. Now I got whatever is required, so I'm killing the rest. So Docker rm -f dollar docker ps -a -q. Okay. Okay. Then now what I will do is, I have a Ubuntu image which can ping. This is something which you require for testing single host networking, right? So then I'll go back to the basics of Docker networking, and then I'll come back and reuse this image. Okay, because this image will tell me about something which is very important, right? And later on I'll be creating my own network and using the same image. This is my test image to test the networking functionality, right? Okay. Now let me go to the blog. Docker networking. Yes. Okay. Fine. Initially, Docker networking was part of your Docker engine. Initially, Docker networking was part of your Docker engine, very tightly composed. Not, I will not say part of Docker engine. It was part of Docker daemon. So part of your then basically what used to happen was, doing something different in networking was not that great. Okay, like all the virtualization technologies, even when VMware started, it was not so good in networking, but after some time it has stabilized. The same thing is happening to the Docker right now. Okay, but now it is very much better than what it was in 1.8 or 1.7. When you, if you have worked in Docker in 1.6 or 1.7 versions of Docker, the networking was not that great. Okay, to enable communication between two Docker containers, we used to use a concept called as linking containers. We used to use a concept called as linking containers. Okay, what we used to do is, in one container we used to link the other container. Okay, and then we used to pass the container name, which becomes an environment variable within the container, and then you have to use that to find out the other container's details. Very stupid concept. Now if you look at it right now, it looks as the most stupidest concept, but at that time it was something. Yeah, it enables two containers to speak with each other, but now we don't do that. Now we don't do that. Fine. So when you think of Docker networking, there are three pillars. Okay, those are some. The first one is CNM, container network model, and then you have something called as lib network. And in today's class itself, I have said that whenever you see something called as lib, what does it mean? It is a custom implementation of Docker. So Docker has created its own networking component, which is lib network. And then there are drivers. And then there are drivers. Right? Now, let us come back to it. What is CNM? CNM is nothing but a specification document, how a container's network should be. CNM is nothing but a requirements document అనుకుంటా. It where Docker has defined, saying that this is how the networking of Docker should be, right? And now, if you want to go through the CNM, there is a link over here. It is a GitHub page where you can get into and find out what are the different things that are present over here. All right, that is a specification document. All right, much like how you specify protocols, TCP ante ela undali, HTTP ante ela undali, how this is how they should communicate. Okay, the whole point, it is a specification document, right? It is nothing but a very basic spec from Docker. Now, what is lib network? Okay, lib network is its implementation. CNM's implementation from Docker is lib network. All right, but here when we speak of implementations, okay, before we go to implementations, like CNM, there is one more standard. CNM is container network model. This is from Docker, and this will define how the Docker networking should be. But Google or the other community has defined one more standard, that is CNI. That is what is mentioned in this slide. CNM versus CNI. CNM is Docker's native networking model. It will tell how the Docker's networking should be and all of that. And CNI speaks about container networking. It is not specific to Docker. It is specific to any container technology, right? And basically, when you use Docker Swarm, you are using CNM. When you are using Kubernetes, you are using CNM, right? So that is the first difference between Docker and Swarm. Purpose is same. Why you use both of them is to achieve the multi-host or multiple containers running in multiple machines across the world. That's the whole point, right? So to achieve that, there are two different specs. One is CNM, which is from Docker, which is what we are trying to look at right now. But in Kubernetes, whenever you are doing any networking, it is not CNM, it is CNI, right? So basically, CNI is defined by CoreOS. Okay, CoreOS is an operating system which is Linux based. Okay, especially designed for container technology, Linux stuff. So those guys are the owners for that. Okay, when it comes to here, Docker Inc. is the owner for it, right? Container networking model is used in Swarm. Container network interface is used in Kubernetes, right? So we have a competition here. Fine. When we come across CNM, these are the important terminologies. There is something called as sandbox, there is something called as endpoint, and there is something called as network. CNM defines these terms: sandbox, endpoint, and network, right? So now all of these things are basically implemented using lib network. CNM is a specification, lib network is an implementation of it. Okay, by looking at a requirements document, you have come across and you have implemented one product, and that product is lib network. That product is lib network. Okay, and basically lib network also does one wonderful thing. It gives you way to extend your network. మీ సొంత నెట్వర్క్ ఇంప్లిమెంట్ చేసుకునే కేపబిలిటీ కూడా ఇస్తుంది. All right. So let us get into that. That is drivers. A driver is a specific protocol implementation. A driver is a specific protocol implementation. You are seeing drivers like overlay, MAC VLAN, IP VLAN, bridge, all of this, right? These are the implementations. Lib network is a conceptual implementation of the CNM, where it will define or come across or implement things like sandbox, endpoint, network, and how the network should behave. These are all the traditional networking technologies. Bridge network, overlay network. Okay, they're all existing networking technologies. Those are implemented in Docker using drivers. So for example, if you want to have your own custom networking, then you will write your own driver. That's the whole concept around it. Right? In CNI, can't we do this? You can do that, but the terminologies are different. Right? So CNM, what is the next thing? Lib network, and then driver. Driver is implementation of your networking standard. Okay, lib network is the core part where you basically try to define something out of CNM. All right. So for example, if I have to say it in basic words, think of CNM as a Java specification, right? Lib network as JDK, which will help you to do something, right? And driver as your application which your company is developing. So language specification, compiler, and then your application, exactly the same thing, right? So first is standard, the second one is implementation, the third one is the environment where you can basically implement what is that you want. But here, since it is networking, we'll be implementing only networking aspects of it, right? Okay. Now, for the people who are from networking backgrounds, I am quite sure that you might have come across terminologies like control plane, data plane, and all of that. If you are not from that side, I am sorry for this slide. All right. So I thought there will be some networking engineers for whom it would be interesting. So if that is not the case, forget about it. Fine. Good. Now see what it looks like. We have a Docker engine. Okay. And then we have something called as lib network, which is external to Docker engine. Yeah, it is shipped as a part of Docker engine, but it is not very much sticky. It is basically a component of the stuff. In there, what we have some basic networking implementation or networking services which we expect. So we want service discovery. DNS. DNS tells andarki? Yes. So how many of you don't know what a DNS is? Okay. Are you typing google.com? Yes. Okay. But your browser will not be able to communicate to the other system, okay, by its name. It can do only by its IP address. Okay. So whenever you type something, it has to be converted into IP address. Right? So who does that? DNS does it. Okay. And this mechanism is called as service discovery, basically. So you have service discovery components over there. Load balancing, I think I have spoken about it and I will be speaking about it. Okay, these are the basic networking utilities which you expect in any kind of technology. So those are all implemented as part of CNM. And then you have drivers. Okay, and drivers, basically there are two kinds of drivers. One is native drivers are which get installed as part of when you install Docker. Remember, while going before a break, I have executed a command called as docker network ls, and there were some things which were already present. So those are all the networking drivers which are already shipped as part of your Docker installation. Remote drivers. So for example, you are not satisfied with this network and you want a custom implementation. There are many third-party companies which are giving you networking components. So you can install from them. You can take a networking driver from them and plug it into your Docker. That's a third party. And obviously you'll have IP address management, which is quite understandable. Okay. IP address management is must and should. Right? Fine. Good. Okay, these are the other complicated areas of this, but I'll try to keep it to minimum. Okay, so whenever you are trying to do anything, if you have remembered me, I've probably in the morning I've created a table where I was telling that there will be a hash as a key and then something as a value. Okay, so this key value is that distributed key value storage. There are some applications which can help you to basically do it very fast, where you can give multiple keys and values. all of your Docker networking history will be stored in key value stores. Okay, this will be evident when we look at Kubernetes. Even in Kubernetes, to store the details about multiple containers, all right, you will be basically using a key value store there. Okay, if I'm not wrong, it uses etcd there. All right, fine. Network gossip is a protocol. Network gossip is a protocol which Docker has implemented. We need not know all of this. I have just put it because these for the people who are interested in learning the deeper ways of how Docker networking is working. You can get into and explore all of those areas, right? And then encryption is supported, which means that you can basically host https or encrypted stuff on your networking. You have service discovery. One service discovery I just said right now, which is DNS, very simple service discovery, which has to be present, right? And then obviously you'll have IP address management, right? So whenever you take Docker network, you are getting all of this. You're getting all of this, right? For all of this, we have a wonderful command, which is Docker network, right? And if you remember, that was a command which I have used. So let me go over here and type something called as Docker network, sorry, network ls. So what is that you are saying? I am saying three values over here, and then I am seeing three drivers. If you see, if you observe closely, driver is bridge driver, host driver, and there is something called as null driver. Null is no networking. I don't want network. Okay, and then you have something called as host and bridge. Okay, these are the different driver implementations of it. Fine, it's okay. Now let me try to do create my container. So do I have any container running? No, I don't. So let me run one container. Docker run minus it. Okay, so Ubuntu. Let me not run Ubuntu. We have certain containers already, right? Tomcat is a container which we have yesterday we have built. Okay, so and GOL also. Any container is fine. So let me run GOL. So GOL colon. We have latest container on this. Do we have? Okay. So let me use run it in detached mode. Yeah, we have GOL colon 1.0. Okay, and I'm not interested in ping. I am not interested in port stuff. So what I will do as one thing is I'll create a name which I will call it as C1. Making sense? So I've created a container whose name is C1, which is GOL 1.0. Okay. Now I'll basically create one more container which is C2. Right? Now let me say Docker network ls. So what is that I'm saying? I'm saying network three network IDs. So let me try to do this. Docker network inspect bridge. Okay. Spelling tapa. Oh, fine. In inspect, are you seeing anything section over here which has something to do with our containers? C1 and C2? Yes. So it is trying to tell that in this network, now currently I have two containers which are running, which are C1 and C2. C1's IP address is 172.17.0.2, and basically the C2's network is. So shall we try to see whether these two containers are able to speak with each other or not? 0.2 and 0.3, right? Now let me log in into C1, which is 0.2. So Docker exec minus it. Okay, and what was the name of it? C1. Okay, slash bin slash. Okay, do I have ping? Yeah, fortunately, yes. So I'll be executing ping C2. What is happening? I don't know it. right? What is the IP address? 172.10.17.0.3 working? Yes. So will these two containers will be able to speak with each other by networking? So we have not done anything. The basic default network driver that was present on your system was a bridge driver. Okay, and bridge is establishing the communication between two containers which you have created. Okay, but there is only one problem to it. It is not able to resolve by name. It is able to resolve by IP addresses. Right? But even this is good. This is good for most of our concerns. Right? Now, so is the networking between containers happening? Yes. Yeah. It will not happen if you use host network, because host is a network that is defined between your laptop or the place where you have Docker and your container. Null is create a container without a network. Null is create a container without a network. Now, basically these are all the commands which it speaks about. Okay, and whenever you see scope, if the scope is the same machine, it will say local. If the scope is multi-machine, in the Docker it will tell swarm. If the scope of your network is it can go across multiple networks, we call it as swarm. If it is single stuff, we call it as local. Right? Now, this is what our motive is. Let us try to create a single host network first and then a multi-host network, right? And this multi-host network is specific to the swarm. So when we go to the Kubernetes, we will not be using this. We'll be using something else. But at least we should understand that how this multi-host networking works, right? Fine. So single host is this. So whenever you install Docker, what happens is Docker creates a software-defined network called as bridge network. So how does the bridge look? Is bridge will look something like that. Okay, and whenever you create two containers, okay, let me not come back to that slide. Let me just look at this image. So in this image, what is happening? You have one container, two containers being connected to the same network. And remember, the scope of this network is only one machine. Okay, you cannot use this network to connect to the other machine. So for example, you have two machines where you have Docker installed and you want to communicate between these two. Not possible using bridge, because the bridge's scope is same machine. Okay, so in this same bridge network, if you try to create multiple containers, right, they can communicate with each other. Right? For example, if you have basically app server and DB server, you will create app server and DB server in the same bridge because they can speak with each other. But still we have one problem. They are able to speak each other by IP addresses, but not by name. Yeah. So what we will do is, now let me create my own network. I want to create my own network. So shall we do that? I think you are seeing the commands over there. So for the people who are very much worried about commands, I think I have tried to give Docker there. Remember, D is small there when I type. Basically, PowerPoint has done that formatting. It's not my mistake, right? So yeah, Docker network create, and then you try to give the name of your network, right? And then the driver. So what is the driver which I want to use? I want to create communication between multiple containers in the same machine. If it is host, it will not work that way. Host is a communication between your machine and your container. It is not for multi purposes. So my driver which I am going to use is bridge. All right. And then what are the other details? It is asking what is the subnet which you want to do. Yeah, I'll give that. So I'll just say subnet is okay. Let me give as 10.10.10.0/24. Okay, so for the people who don't understand this convention, please Google for something called as CIDR, but I will put it in a simple way. What do I mean by this statement is, I want containers to be created in a network, okay, with IP addresses which is 10.10.10.x, 10.10.10.x, where x is any value between 1 to 254, where x is any value between 1 to 254. So I can create 254 containers in this network. That's the whole point, right? So let me click. Is that enough? Yeah, I think we have to give the name of our network. Name of my network which I want to give is, let me give qt hyphen. So name of my container is bridge. Okay, the network range of this is whatever I have entered there. All right, now let me do docker network ls. Are we seeing our container, our network now? So this is your custom stuff, right? Now let me kill the existing containers. But do we remember the existing containers? What I have done, I have created two containers called as c1 and c2, and I was pinging in between those two containers. And when I was pinging between those two containers, ping by name failed, ping by IP address succeeded. Okay, please remember that. That is very important for whatever step which you are going to do next. Yeah, that is the subnet which they have defined, default subnet. Okay, fine, I have removed them. Now I'll try to create the same stuff whatever I've done basically earlier. Okay, yeah, okay, but with one small change. Okay, with one small change where I'll be giving one extra option which is called as hyphen hyphen network, and I will be telling what is the network this container should be in, right? So now I will tell hyphen hyphen network, and our network's name is qt hyphen. Simple. Yeah, exactly the same work, but this time I'm trying to create on a my newly created. Wonderful. Let me do the same activity and let me call this time the container as C2. Okay, first let me do this docker inspect c1. I am inspecting container 1. Okay, so is your is your network address IP address 10.10.10.x, is it matching whatever we have given? Yes. And then you have other details also. I'm not worried about other details, but if you see networking section over there, network says that you have used a network which is called as qt bridge, and these are your container details. Now let me inspect c2. Are you seeing similar thing? 10.10.10.3, that is my c2. Now shall I log in into this and basically check the stuff? Okay, before I do this, let me do one more inspect, which is docker network inspect qt bridge. So in this there should be containers section, and in that container section there will be name of two containers, and it would be, there will be details of it. Yeah, so in my newly created container, my newly created network, there are two different containers. Fine. Now let me log in into one container, docker exec minus it c1 slash bin slash bash. So ping 10 dot 10 dot 10.3. Working. Wonderful. This we know that obviously it will work. Now let me try this. Ping. Working. All right. So the point here is, whenever you create your own bridge networks, service discovery will be on. Whenever you work with default bridge, service discovery will be off. So DNS resolution is already present, but the only point is, by in the default network it will be disabled, but when you create the same overlay network on your own, you will get this. So if you see now, the difference between this and the existing bridge was, in the existing bridge I was not able to resolve by names. Okay, but if I create my own bridge driver, I am able to resolve by names as well. That's the difference, right? The reason is service discovery is enabled in your network, in your network driver, and service discovery was disabled in the default driver. Was disabled in the default driver. So DNS resolution గురించి మనం కొత్తగా చేయాల్సిన పని లేదు. So what would happen is your Docker engine will act as a DNS server. Your Docker engine will act as a DNS server. Okay, it listens on port 53. So for the people who know DNS, that is the default port for DNS resolution. Whenever a container tries to, you give any IP address to the container, first it will basically, there will be something called as DNS locator on your container, very small component. The responsibility of that component is forward request to your Docker engine. And your Docker, in your Docker engine, there is already a DNS server or a very simple DNS server. What it does is, if call is coming from a network and it is asking about anything in the same Docker network, it will try to give it immediately. Okay, anything outside network like google.com, ping google.com also will work. That is because your Docker engine will resolve it for it, right? But if it asks about a different container, for example, there is a, I have created a new network called as another bridge network. In there I am putting C3. If I do ping C3, it will fail. It will not give you its IP address, because those are two different networks, and the relationship between these two networks is not established because of security reasons. Because of security reasons. What do I mean by that? I create C1 and C2 in one bridge network, C3 and C4 in one bridge network. Can I do ping C3 from one other network? Not possible, right? Within the same bridge network, can I resolve by names? Yes, right? That's how it works in a single host mode, right? Looking good now? So for the people who have been thinking, how do I communicate between two containers now on the same machine, do you have an answer? In your config.xml file, give the IP address, or in your connection string, give the IP address of the other container. Things will start working, because there is already an established network between these two stuffs. Simple, right? Yeah, this is single host networking. Okay, single host networking, basically we use something called as bridge. Okay, if you are going to the Windows world, we use something called as NAT. If your Docker was on Windows servers, you will not have a bridge network there. You will have something called as NAT, right? Not NAT, NT, sorry. NAT is some other server altogether. I'm sorry, I was speaking about NAT and I got that name. Okay, Windows NT network, right? Windows has its own way of network. So the network which you are seeing bridge, okay, bridge might not be bridge across all operating systems. They might have their own implementations. Okay, but you will have something like bridge, which is responsible for communicating between the same machines, right? Are we good? So Windows machines lo bridge undadu. If you try to create, for example, if I'm speaking about the same example in Windows containers, I might not speak about bridge at all, because there is nothing called as bridge in Windows. There is nothing called as bridge in Windows, right? So is it making sense now? Yeah, okay, we have done exactly this. Okay, but the names are different. He has used PS bridge and we have used Qt bridge, but this is what we have done. All right, so this will solve our problem to some extent. Good, looking good, better than what we thought. All right, so this we have done already, ping C1 from C2. Now how about this scenario? I have two different machines where I have two different Dockers installed, and now I want to ping a Docker from one machine to the other machine. Is it possible? Bridge? No possible. Not bridge, it is not possible at all. Okay, so I'll stop till this point and let me look at if we have any questions. Can we enable service discovery in default network? There is no need for it, because once you go into the enterprise world, you will not be using default network at all. You will always create your own network for every deployment which you are trying to do, because we don't want unnecessary communication between unnecessary containers, right? For example, if I'm deploying for an e-commerce application, I'll create a network for e-commerce application saying that Docker network create e-commerce -network, and then I'll give some subnet range, and I want only the containers which are doing e-commerce in that network. So we'll not even try for that, and default networks behavior we cannot change. Okay, if you want any customizations, go and do it on your network. Yes, okay. So what was the other question? In if two containers are present in the same machine but different networks, whether it is possible to communicate with each other. In that case, basically you have to think of some sort of a solution, all right, which is like tunneling or VPN. So do you want to go to that extent in the same machine? No. రెండు నెట్వర్క్ల మధ్య కమ్యూనికేట్ చేయాలంటే ఏం చేయాలి? అయితే రౌటర్ పెట్టాలి. You have to write your own router. Or since they are two different networks, create a VPN between them. For two simple networks which are running on your system, will you do that? The answer is definitely no. That's the whole reason why we go with multi-host networking. Right? We go with multi-host for that scenario. This is not this is a very basic network, single host. So that's why it is not very well expanded. We don't have very customizations on that. So for all of your answers, for all of your questions, my answer is multi-host network. My answer is multi-host network. So when you want something to be communicated, one ground principle is they have to be on a same network. They have to be on a same network, right? Good. So multi-host network scenario, this is our scenario. We have three different machines, and in all the three machines we have installed Docker, right? In machine 1 there is a container, in machine 2 there is a container, in machine 3 there is a container, and I want to enable communication between all of these. Challenge, right? Yes. So this is where multi-host networking will come into play. ఇప్పటి వరకు మనం మాట్లాడుకుంది అంటే ఒక్క మెషినే ఉంది, నా దగ్గర ఒక్క డాకర్ ఇన్స్టలేషన్ ఉంది. I have only one docker installed. But now I have three machines where there are three different docker installations, and I have to enable something like this. So this is a multi-host networking scenario, right? So this comes with its own complications, right? So can I enable multi-host networking between any two applications, any two machines? My answer would be yes, as long as they are reachable to each other. Let me reframe my sentence. Can I create multi-host networking between two machines where the Docker is installed? What is the prerequisite? Those two machines should be able to ping with each other first. రెండు మెషిన్లు ఎక్కడ ఉన్నాయి అనవసరం. Whether they are in the same building, different building, that's a different story. But there should be some sort of networking established between these two machines first. Okay, and that is what we call as underlay. This part. If you see these machines have different network IDs. One is 192, the other one is 172, the other one is something else. But they are pingable to each other. This should be established. This should be established. If this underlay, if these machines are not able to ping with each other normally, then Docker networking also can't do anything. Because if you are using Docker networking, you are using that underlay layer. All right? Are we good? Yeah. So let me log in into this machine, which I have created just now. Okay. Install Docker very quickly on these machines. I have two machines. Docker ext. Okay. Where is downloads? Okay. Downloads. Okay. Wonderful. Fine. But what is the problem? Okay. But this will be confusing. We have two machines, right? So what I would do is, as usual, let me not do this. అలా ఏం కనబట్లేదా? Okay. To the people on the web, they might not have this much problem, but yeah. That's fine. Now looking better? Yes. So this is a Docker ext1. Now I have to do this activity again, but on the different machine. We have three machines. The problem is I have to somehow three machines have to look different, right? So options, background, Let us see. Okay, this is docker ext 1, and then I'll have docker ext 2. So let me log in into this docker ext2. Just for us to identify that these are 3 different machines. Otherwise, we will not be know in which terminal we are working. Right? Okay. Fine. So we have 3 machines, and we will be having Docker on all the 3 machines. Right? So first, let me do the steps to get Docker. Copy this. Okay. Okay. Let it do its job, and in the meantime, fine. So I have 3 different machines where Docker will become ready. As of now, it might not be, but 3 different machines. All right. Okay. Fine. So then let me do this. This is required, right? If you don't do this, what would happen? You have to become a root user to access Docker. Only Docker client will be accessible to you, not server. Why it is not. Okay. The same thing over here. And once you do this, you need to log out and log in. If you remember, these were the same steps which I did on the day 1 when I wanted to install Docker. All right. Now let me do Docker version. If it is giving client and server version, you are good. If you don't use that add step, right, sudo add step, you will be getting only client version, and the server you will be getting error saying that you don't have permissions to read docker.sock, and you cannot basically access what is happening over here. So let me go back to my slides. So at least do we have 3 machines now, right? On these 3 machines I can launch 3 different containers, but the problem is I want these 3 containers to speak with each other. The problem is I want these 3 containers to speak with each other. It is not possible by the default networking which we are looking at it right now. For that, we need to go with a multi-host network. And multi-host network, the default multi-host network that is present is called as overlay network. What is it? Overlay network. The first condition for that is all these 3 machines should be reachable to each other. 3 physical machines should be reachable to each other. If they are not, forget about Docker networking, multi-host network. Okay. To ping, they might not be at the same location. One server could be in US, the other server could be in India, and they could be able to ping with each other, right? So that's a condition, not the location. Location is not a restriction. They should be physically be able to communicate with each other. This physical networking part which we have established is called as underlay layer. The layer which you are seeing underneath these nodes, which establishes network between these two. Now, then whenever you create a Docker network, you will be creating a Docker network which is called as overlay. Which is called as overlay. Overlay will look as if they are communicating directly. ఓవర్లే నెట్వర్క్ క్రియేట్ చేసిన తర్వాత ఎలా కనబడుతుంది అంటే ఒక కంటైనర్ ఇంకో కంటైనర్ తో 2 డిఫరెంట్ మెషిన్ లో ఉన్నా డైరెక్ట్ గా మాట్లాడుతున్నట్టు అనిపిస్తుంది. బట్ యాక్చువల్లీ దే ఆర్ నాట్ స్పీకింగ్ డైరెక్ట్లీ. దే యూజెస్ దిస్ ఓవర్లే నెట్వర్క్, అండ్ ఓవర్లే basically uses underlay, right? But logically it will look as if overlay is speaking with each other, right? So this will take us to a concept called as tunneling. So for the people who know tunneling, right, so this is what it is all about. Now let us see what happens. We have 2 machines, right? And the first thing is your underlay should be correct, which is 2 machines pingable to each other, right? Then this is what happens. There will be a tunnel that will be created, but remember, this is a logical tunnel, not a physical tunnel. This is a logical tunnel. So దీంట్లో వెళ్తున్నట్టు అనిపిస్తుంది కానీ యాక్చువల్గా it is using underlay. It looks as if it is going through tunnel, but actually it is using the underlay layer, right? So what will happen is there will be an endpoint that will be created. endpoint that will be created at every node. And whenever your Docker container wants to speak, okay, it will be speaking with an indirectly created bridge network. Indirectly created bridge network. That bridge network will take it to the endpoint. Endpoint will take it to the tunnel. So whenever you create a overlay network, you will also be getting some sort of bridge. So that bridge is for logically speaking with the endpoint. So you will be getting two stuffs, right? So it will look as if it is bridge, but it is not bridge. Now, is it making sense? So whenever you want to communicate from here to here, what would happen? You would have a virtual Ethernet connection which will go to the sandbox, and sandbox will take it to the virtual endpoint, and endpoint will take it to the VXLAN tunnel, right? And VXLAN tunnel will take it to onto the other side. This is all logical. This is all logical layers. Physically, the same underlay connection. And remember the port numbers which you are using, it will be using UDP ports. It will be using UDP ports. So whenever you are using it on AWS, ensure that you open those ports, or while you are trying, open all ports. Open all ports, right? Fine. Now, how do I do that? Looking good, but how do I do that? First thing which you need to do is you need to identify what is your main server. In when we go to the swarm, we will have a concept called as master, which I'll be speaking at the later point of time. In one machine, you will go and initialize Docker swarm init. In one machine, you will go and initialize Docker swarm init, and basically on the other machines you will join to that swarm. You will join to that swarm. All right. So shall we do these steps? These steps first. So let me go onto my additional actual server which I have been using. With all due respect to this, because it was helping us a lot, let us make this as a manager, right? Because it was serving us for the long time. So let me remove all the existing containers over here. Docker minus a. Okay. What is happening? Docker rm minus f ps minus a minus q. Good. Now, so this will become our master. All right. So let me just execute Docker swarm init. All right. So it says that, okay, this is your manager. All right. And now rest of the things will become workers. And to make workers, you copy this, all right, and add it in your workers. So I have two workers now. One which is green, the other one which is blue. Yes? No. So I have nodes that have joined as a worker. So I have three machines set up now. Okay. So now I will go across a special command which is called as Docker node ls. So how many nodes am I seeing now? Three. So do I have three nodes basically, right? So there is some sort of communication that is established now. Now let us see what is next which I am supposed to do, right? Okay. The following port should be open. I have a protocol where everything is open. My security group, everything is open by default. Now we have created the bridge network in the earlier case. Now let us create overlay network. All right. So let me blindly copy this one. I am fed up with typing. Okay. So let me copy only till this point. This looks good. Okay. So I'll be going over here and then I'll be saying Docker network. Okay. Now let me do Docker network ls. Okay. We have created one overlay, right? Yes, which is qt over, right? But are we getting something extra? What are the extra? There is something called as ingress, and there is something called as Docker underscore GW bridge, which was not there earlier, right? This bridge is your BR0 in the diagram. Whenever we have seen in this image, you have a sandbox environment, right? Sandbox environment will create a bridge network, I said. That is what it is trying to do, right? And ingress network, which we are seeing right now, is beyond the scope of our discussion, but I'll tell you what it is. For the people who know something called as routing mesh, that is what it is. And for the people who don't know it, please leave it, all right? Because I don't want to get into swarm too much. This is all Docker swarm terminology, all right? Okay. Now things are good. Now what I would do is, I would say that I want to create 3 containers now. I want to create 3 containers. So let me do this. Okay. So whenever you want to create one container, you will be basically using a command called as docker run ls, docker run command. But here what we are trying to do is, we are trying to create a same application on 3 different machines. All right. So for example, let us assume this is our Nginx. So what is that I'm trying to tell is, I want 3 Nginx containers to be created. Why 3? Because my load might be more, right? Why 3? Because my load might be more, right? And for that, I'm not calling it as run, but I'm calling it as service create. I'm calling it as service create. Multi-container terminology in the case of Swarm, or even when we go forward in Kubernetes, we'll have something called as service. So this service is basically a combination of different containers, right? They can be running on the same machine or a different machine, that could be your choice, right? So let me go over here and execute this command. So how many containers I am telling now? 3 containers. Good. So don't worry about these command lines. PPT lo nundi nenu elagaithe copy chestunnano meeru alage copy cheskondi. Okay. And if you want to know more about that command, anyway I said what has to be done, go to the Docker command line and just search for Docker service. You will get all the information of what is here. So don't worry too much on command lines. నేను ఎవరో వచ్చి మీరు కమాండ్లు చాలా ఫాస్ట్ కొడుతున్నారు సార్ అన్నారు, నాకు గుర్తులేదు. బట్ ద హోల్ పాయింట్ ఇస్, నేను ఎందుకు కొడతానంటే నేను కాపీ పేస్ట్ బాగా చేస్తాను కాబట్టి. Okay, then there is nothing apart from that. Other than that, the only thing which you have to remember over here is Docker service. Go to the Docker documentation and see, look at those command line references. That will help you. All right, fine. Let us see what it does. On one machine it is running because we already have an Nginx container. On the other 3 machines, what is happening? Basically it has taken time, right? So things are good. Now Docker service ls. So what is my service? qtsvc. How many? I said 3 containers. It is telling that 3 containers are running. So but I don't know where they are running. To be very specific to you, I don't know where they are running. So Docker service inspect, okay, qt-svc. Okay. So are you seeing this virtual endpoint, virtual IP? This is the virtual IP of your server, of your basically the machine which you are trying to do. Okay. And then let me just go down and there will be something interesting which you will find. Come on. Okay. So not here, not here. Interesting part is not here. Sorry for that. Okay. Interesting part comes in, okay, when you try to go onto the other machine and you do docker ps. So if you see on the blue machine or on the green machine, I have not executed a single command after I have installed Docker. The only command which I have executed is docker swarm join command, which I have copy pasted. But am I seeing a container which is running over here? Yes. Okay. So docker ps. Am I seeing one more container running over here? So who has initiated all of this? One machine is getting the containers running on the different machines. This you will take it to the next level when you speak about orchestration. How will I speak with these containers which are running on multiple machines? How is it this happening? All of this stuff. Now I have spoken about a stuff which is very much swarm. but I want you to take it to the Kubernetes, where we will be discussing about these kind of things. We are not single machine anymore. We will be having Docker at multiple places, and then we'll be controlling it from one or two servers. Right now, let me go back to my manager and execute one more command. So I want to create one more stuff, which I would call it as Qt GOL. All right, and then what is the image? GOL colon 1.0, and I don't want to sleep it. Okay, let me use this minus p 80 colon 8080. Let us see what will happen if we do this. No, I don't want to take you to guesses. So let us not do that. Okay, so whenever you're in service, the things will work slightly differently. If you see on one machine, it has got basically found immediately. On the other two machines, what is happening? Why? What is the reason? It is unable to do the stuff because where is GOL colon 1.0 present? In your local machine. Have you pushed it to the Docker hub? No, that's why it is failing. That's why it is failing. So whenever you want to work on multiple machines, your images have to be present at centrally located repository. In our case, that is Docker hub, right? So this will never work because it will never know what GOL is. Okay, one way how you can make it achieve is go into that machine and manually create GOL, which doesn't make any sense. So whenever we create images, we have to push it to the repositories. Remember that. That's the first rule, right? So now let me basically do some more stuff. Docker ps, or let me basically run Tomcat now. Tomcat will not be creating that much of trouble. Why? Tomcat. This is in Docker hub. Making sense? All right. So whenever you are running these kind of modes, ensure that your image is accessible from every Docker engine which you have created, not only in one machine. Right? It might take some time because it has to download and do all of the stuff. It is just waiting for the things to be stable. It has verified, service converged, things are good. Now, if you see all of the stuff, I am basically controlling it from one server, and it is able to go and create containers on other machines. And these containers will have a network. Let me just do Docker ps. Okay, so if you see the names will no longer be like just the name which you have given. There will be some extensions which will be added to it to basically add to the swarm. Now let us not worry about it. Docker. Okay, so if you see what has happened over here, GOL ఎన్ని ఉన్నాయి ఈ machine లో? Since on the other two machines it was unable to create, it has created all the three containers in the same machine. You wanted three, it has given you three. On the other two machines it was unable to, because there is no image called as GOL colon 1.0. In this machine there is a image. So what it has done? It has created all the three machines in the same server. That's the whole point. So it works in this unique and fashion. You don't need to tell where to launch. It will basically take a decision on whatever it is. Right? So now let me basically try to inspect this. Docker inspect. See the network. What is the network? Oh, this was the older one. Didn't I give the network? I have given service, right? Yeah. Okay, fine. Okay, so basically the whole point what is happening over here is it is trying to create multiple machines or multiple containers from one stuff, and it is able to establish communication between these two. Now let me try to simplify what you will be doing in your real time. You will be creating three services: one middleware service, backend service, front end service. Okay, now why service? Why not containers name? Because your containers might kill your containers might come down or go up. If you give one particular container's IP address and if that container is killed, what will you do? So that's why we will operate from one mode of communication to the other mode of communication by its service name. And every service will have a virtual IP address. Every service will have virtual IP address. For example, we all know that we have to go to the web.xml file and give the IP address of our database server. But we will not give a name of our database IP address. We will give database services name, because it will connect to any other database which is running, rather than sticking to one particular machine. So we will move away from speaking about one containers, but we will be speaking about small group of containers which we call as service. And these services, right? Okay. For example, if you look at Docker service command, okay, are you seeing a command called as scale? Yes. So each service is a microservice, a part of your application, and you can scale your application separately. So for example, I create 3 services called as admin, registration, sales. As on today, registrations are happening a lot. So I need to just scale registration services. Rest of the 2 same. So you can individually scale services. If you remember, I have started my class saying that Docker is very good for microservices. So this is all what the Swarm has. Okay. But we have to discuss on what Kubernetes also has. What Kubernetes also has. So very important, guys. Whatever concepts which we have discussed till now, please go through it once again, right? Once I go to the Kubernetes, I'll be not be speaking about Docker's concepts like what is volume, right? What is port forwarding? No, right? Because we have our own set of headaches when we speak of Kubernetes, right? So in Kubernetes, I'll be speaking about multiple containers at one shot, not single containers anymore, right? 3 వెబ్ సర్వర్లు ఉన్నాయి, ఓకే, 30 మిడిల్వేర్ సర్వర్లు ఉన్నాయి. That's the convention is more now. It is multiplier. It is not no longer singular stuff. So how do you deal such stuff in an orchestration suite, which is basically making more sense? Now suddenly, if you have seen what we have done, when we were discussing one machine scenarios, it was not looking real time. Yes or no? Okay. Suddenly, when I made this multi-host networking, it started, yeah, this is how probably our services will be working in the office, because we don't have a single point of failure now, right? Even if one container is killed, it is automatically launching one more container. And I have shown you one thing where I have created game of life, and game of life image was present in one container, and it was intelligent enough to create all the 3 containers in the same machine, because that is the only place where you have game of life. It has not thrown an error, right? All of this is what makes you closer to the enterprise world. All right. So in orchestration, if Kubernetes, if we compare orchestration to the web searching, Kubernetes is like Google search and Swarm is like Bing, right? So both are good, there is nothing wrong. Bing is not bad at all. You try to search in Bing, Bing is wonderful, no doubt about it. But people generally use Google search a lot, right? In the same way, people are using Kubernetes a lot. That's the whole point why we have a lot of jobs in Kubernetes, not in Swarm and other technologies. So that's why we are trying to learn Kubernetes. There is no other reason, no other technical stuff. But if it was 1 year ago, if it was 1.5 years ago, Docker Swarm was not capable, or not even in a position to compare itself with Kubernetes, right? So we'll be starting our discussion on Kubernetes. But is it looking good? Don't worry about the commands. This is not what we are doing. This is not what we are learning. But today, what I wanted to show is it is possible for you to create 3 different containers on 3 different machines and make it speak with each other. That's the whole point, right? Yes. Okay. Now let me look at questions and let me basically think of. I have put some scenarios somewhere else. I'll try to open that. Yeah, we are doing same as Kubernetes with Swarm. Yeah, the purpose is same. Kubernetes and Swarm, the purpose is absolutely the same. All right, but people are using Kubernetes a lot, so that's why we would deal with Kubernetes. All right. Is Docker services a stack? So I would not put it in that way. If you are asking me about Docker stack is I cannot say that it is always a service. Yeah, Docker service and Docker stack has something in common, but not the same stuff. They're not exactly the same. All right. Multi-machine model works with Swarm and Kubernetes, will it not be possible with Docker? Not. So Swarm is already part of your Docker. So మన కొత్తగా Swarm ఏమి ఇన్స్టాల్ చేయాల. Did we install anything? No. So Docker and Docker Swarm, Docker doesn't want to see it as separately. So when you install Docker, you are getting Swarm already. So that's why I would say that it is default present if you want to use Swarm. But if you want to use Kubernetes, you have to do something extra. All right? Yeah. If two containers are present in same, I think that I've spoken about it. Establish the network between hosts, created the overlay, created service on the master, which will establish the replication on the nodes. Right, absolutely. Replication on the nodes. I would not say replication on the nodes. I'll say basically first is ensure all the machines which you want to identify as a nodes are reachable to each other. Then identify who are managers and who are workers. Go into the manager and execute a very simple command called as docker swarm init. So you're initializing a docker swarm mode of networking. Swarm mode is nothing but multiple machines mode. So you will get, once you execute that command, you will get a command line saying that, okay, this is what the command we need to execute if you want to add another worker. Copy that, go into your workers, execute that command. So your swarm is ready. Once you have that swarm, now you have a multi-host basic stuff. Now create a network. Create a network which is overlay. And once you have a network which is overlay, go ahead and create something called as service, which can create the same service on more than one container. Which means you are doing scaling. So when you want to communicate from one part of your application to the other part of application, you will be communicating via service names. Because every service will get a virtual IP address. That's the whole point. That these are the steps. If you want to follow in Docker Swarm, you don't do anything beyond this, right? Okay. How to monitor containers apart from Docker stat? So there are multiple ways of doing that. So for example, if you go to the Docker enterprise installation, this is automatically enabled. So if you take Docker enterprise edition, which is a paid version, okay, when you log, it will give you a web front end where you can log in and find out the status of your containers, whether they are working, not, and all of that. All right. But if you want to do it in an non paid mode, you have to write something like Nginx or some other kind, something like Nagios or some other monitoring service on your own. By default, you will not know it. All right. Yeah. Is service setup of the container running? Service is nothing but a container or multiple containers which does the same job are called as services. Right. So if you are running three Tomcats on three different nodes, we don't create three different containers at three different machines. We create a service which is three Tomcats in this Swarm cluster. It can create it at any place. And remember, whenever you say replicas as three, మీరు క్రియేట్ చేసేటప్పుడు replicas 3 అన్నారు. రెండు సర్వర్లు షట్ డౌన్ చేసేయండి. Okay, then what it would do is on one physical machine which is present, it will try to create three Tomcat instances. So it will always try to maintain whatever number which you have told. So if I say replica as 2, in any case it will try to ensure that you have two containers running in that cluster. All right, whether it is one machine, two machine, 100 of machines, whatever it is the case. All right, that is the importance of replicas. All right. Yeah, why you want to avoid that? Yes. Yeah. Yes. Yes. Yeah. Yes. Yes. You cannot stop that, because in any clustering setup, it is not only Docker cluster, any cluster, whenever you say that these are the number of services which I want, it will always try to maintain at every point. For example, you set the network lynch, one server has gone down, so one container is down, it will create one more container. Now that has started working, now it sees there are 4 containers which are doing this job, so it will kill one. That's how the things work. But it will always try to maintain. You can't turn it off. The only way for you to turn it off is go into Docker service command and scale yourself. Scale on the command on the other, reduce the scale. Say from I want, okay, scale was 3 earlier, let me make it as 2 to satisfy the condition. But if you don't use scale, it will always try to maintain the number. That is strictly how it should be. Okay. In any case, if you want to change the behavior, go and change the scale. Scale చేసుకోండి మీరు, నాకు వద్దు 3 వద్దు 1 చాలు. That's what you have to do. But automatically it will not be able to make a decision saying that I should not be doing this. No, just because your network is down. For it doesn't make difference whether it is network is down, machines are not available. It will always try to maintain numbers. Always try to maintain numbers. If you want to change the behavior, go to Docker, service, scale, reduce your number. Right? Okay. In real time, if you hosted a web server using Swarm, where should I point my DNS record? To the service, because service will be exposed on one port, which I have not shown today. I'll be doing all of that in Kubernetes. All right. So Docker service will be exposed on one particular IP address on one particular port on your machine. That is where your DNS record should point out to. Right? Okay. So you have seen something called as egress, ingress stuff, right? Yeah. Okay. So that is what it does the magic. Okay, I'm not getting into that is a core networking concept. That's more than enough whatever we have learned, so I don't want to get into that stuff. One last thing, it is all we have already taken some over time, but let me try to basically do it. Manikanda, do you remember నేను workbooks ఎక్కడో కాపీ చేశాను, ఇక్కడే అనుకుంటా. Let me try to look at this. What is this blinking? Parallel processing. Okay, not this man. Bhaskar, if you are online, do you remember where did I copy that workbooks? ఎక్కడ కాపీ చేశాను, నాకు గుర్తురాట్లా. The items which for the Ansible we have done it in the classroom, right? I have given you some workbook items. ఎక్కడ ఉన్నాయి? గిట్లో ఉన్నాయి, గిట్లోనే ఎదుగుతున్నాను నేను కూడా. ఎక్కడ అని గిట్లో ఏ స్క్వేర్ జోన్ లో ఉన్నాయా? So let me see if I have created something called as workbooks in here. How can I miss workbooks? Looks good. Okay, so the first one which you are seeing, right, deploy Node.js app to production server and all of that, right? So there is one example of an application which they are trying to do, and I want you to create a Docker container for that. That is the only work which I'm trying to give it to you. So if you go to this location, but if you want to do it for a standard app, there is something called as Telform. If you go to the Telform, you will have multiple applications. This we will do when we finish Kubernetes, because there are many services over here. But if you go to this path, okay, it will try to set up Node.js server, and on the Node.js server it will give you some code which you have to put, and then some commands how does the node application works. So I want you to look at these steps. Okay, forget about reverse proxy. I am not interested in reverse proxy. The only thing which I am interested in is Node.js application, right? So in this there is only install Node.js, right? And then basically once you scroll down, create a Node.js application, blindly do whatever he says, right? And your application will suddenly starts working on 8080 port, right? And then for testing your application, he is just asking you to do this stuff, right? So now the only code which you are supposed to copy is hello.js. In the Tomcat file, what is that we have copied? Gameoflife.war is what I have copied. Now I am copying hello.js, right? In the Tomcat application, I wanted Tomcat to be present. Here I am expecting Node.js to be present, right? And after that, your command is just node hello.js. Can you write a Docker container for that, right? Please do this, right? So for the people who are new to this link, go to the github.com a square zone. I'll be copying some stuff into Docker zone. Just give me some time, because I want to add service scenarios, not single machine scenarios, right? So go into this a square zone, chef zone, and in that there is something called as workbook, and in workbook you will have this, The first one is what I'm trying to get it for in there. Once we finish Kubernetes, then we will do about something like this, Terraform, which is one kind of an application, right? Right. So it is a Google Forms alternative, right? We will do it later at later point of time. But if you see, there is Docker file already. These guys are already doing Docker file, Docker mode, right? So don't worry about that. But I want you to do this. This is a very simple application. The only difference is, in the earlier case, our requirement was Tomcat, and we had to copy gameoflife.war. That is what I have done in the classroom. Now what I'm trying you to tell is, I want Node.js. To try to find out how do you get Node.js. You can take this approach from Ubuntu 14.04 and do all the installations by writing run statements, or you can search like what I have done. Is there any container which will consist of Node.js already, so that I have to just copy the file and run this hello.js. So here your command will be as simple as, from your parent image, okay, add hello.js, entry point node, command hello.js. That's it. ఇది అందరూ చేయగలని అనుకుంటున్నాను, ఎందుకంటే ఏం చేయాలో కూడా చెప్పేసాను. Okay, try doing this, and your application will be working on port 8080. Working on port 8080. Try to do this, and if you have any trouble in doing this, you can bring it up to me. All right. So because this is the last chance for us to work on single containers, image buildings, and all of that stuff. After this, we'll be going into the next level, taking Docker to the next level, where we speak about multi-machine scenarios, right? Once we finish multi-machine scenarios, I'll be giving you 3 or 4 applications. I'll give open source application, guys, because I can't give commercial applications and all of that stuff. The only thing that changes in your company is, here you are copying hello.js. Tomorrow when you go to the real-time scenarios, you might be copying a complete zip file, unzipping it, and then running one node application. If you are working on Node.js, నేను ఇప్పుడు సింపుల్ గా ఒక ఫైల్ అంటున్నాను, రేపు పొద్దున మీరు డైరెక్టరీని కాపీ చేస్తారు. Alright, or you will be, if you scroll down in this page, you will be seeing something called as pm2. You can use that, right? Whatever it is. So this is a very simple way, very much relevant to what we have done, and I would expect you guys to at least create an image, right? And one more thing which I want to do is, whenever you create an image, go to Docker Hub, right? Create an image, create a login here, or create a login. You know how to register, right? Get into the site, click on register here, and then remember your username. Right? So once you remember your username, okay, so let me go over here, cd images, game of life. Okay, now whenever you build an image, you should build an image which looks like this: docker build -t, your username of your Docker Hub. So in your companies, you might be using your organizational name, slash game of life colon 1.0. Done. All right, and after that, docker push okay. Oh, I have to log in, sorry. Docker login. Man, I don't remember it. Let me try my luck. నేను లాగిన్ అయ్యి కొన్ని ఏళ్ళు అవుతుంది ఇందులో. Good. What is it I have done now? I have pushed. So I have just done Docker login and then given my username and password of Docker Hub. I have basically done this. Let me go to the Docker Hub now, right? And let us see whether we have game of life or not. Man. అవును. 4 to 6 agile class ఉందా? Okay. Okay. Yeah. Game of life? Yes. That's it. పెద్ద కష్టమేం కాదు ఇది చేయటం. అందుకనే నేను basically what you have to do is create an account, Docker login and Docker push. Tomorrow when you go to your office, you might not be using Docker Hub. In that case, what you can do, I will be showing with Amazon registry, right? Even in that case, it will be as simple as that. You have to give the URL also this time. In this case, I have not given URL. ఎందుకంటే Docker Hub లోనే అకౌంట్ ఉంది కాబట్టి నేను URL ఇవ్వాల. Docker login అన్నాను. And I have given my Docker Hub's username and password. After that, till now we were using pull command. What was the pull command for? Taking the image from Docker Hub and bringing it over here. Push is exactly opposite. Take an image from your machine and make it available into Docker Hub. But remember, whenever you are pushing an image to the Docker Hub, it should have certain naming format. Naming format is your account name slash image name. Your account name slash image. That's it. So మీరు క్రియేట్ చేసిన ప్రతి ఇమేజ్ యూ కెన్ మేక్ ఇట్ అవైలబుల్ టు అదర్స్. సో నవ్ హూ ఎవర్ వాంట్స్ టు బేసికలీ రన్ మై Docker game of life, you can just say Docker pull whatever you are seeing over here. That's the whole point, right? So ensure that you write your image and make it available over here. Make it available over here. All right, fine. So that is what I had. I'll take the questions, and before I take the questions, there is one announcement from Satish. Today evening from 4 o'clock to 6 o'clock there is a agile class, right? Tomorrow from 7 to 10 there is a app server class. All right, fine. Docker machine, Docker data center, these are all enterprise products, right? So we will not be discussing about any enterprise product. All right, any other questions in the room? Is this batch new for agile? A continuation class ఇది అవునా? యా, ఐ థింక్ ఇట్ ఇస్ కంటిన్యూషన్. కాల్ సతీష్ ఒకసారి అడగండి అమ్మా, నాకు తెలియదు. అయినా ఎజైల్ ఎక్కడ నుండి ఉన్నా ఒకేలా ఉంటుంది కదా, జాయిన్ అయిపోండి. 4 క్లాస్ అయిపోయినాయా? అదే ఇంటర్వెల్కి వచ్చుంటారు. రైట్, ఏముండదు, బికాస్ దట్ ఈస్ ఓపెన్ సోర్స్ ఇమేజ్, దట్ ఈస్ ఫర్ ఓపెన్ ఫర్ ఎవ్రీ వన్. సో వెన్ ఎవర్ యు ఆర్ మేకింగ్ ఏ ప్రైవేట్ ఇమేజ్ యూ విల్ హ్యావ్ చార్జెస్ only when some people are supposed to use. Public image, no charge, it is all free. So you need to pay for that private account there. Yeah, okay. Agile start, is it a continuation or starting class? So today evening it is a new class, right? Yeah, yeah. Tomorrow actually there is a class which is conflicting with our application servers class, so you will get a recording of that class. So that's how it is, right? Fine then. So let me stop it at here and let us meet on Monday starting Kubernetes, right? Yeah, thanks. Evening class is only for cloud, not for DevOps. So that's why I'm not announcing here, right? Yeah.